let's make sense of an AP free response, but we're really early in on this stuff. So is their free response going to look just like this? No, but it's some good practice since we're just in the first half of this unit. So it says use the graph to estimate. We got a graph of F, notice that, and then a table of G. Graph of F, boom, table of G, boom. And it says estimate the limit as x approaches 0 of F minus G. So you guys, what we got to do, don't forget that limit notation goes to F and G. Let's go find it. What would we say the limit as x approaches 0 of F is? Hey, he says as x approaches 0, do we agree from the F graph that's going to get me a 2? We cool with that? Love it. Minus the limit as x approaches 0 of G.
2.
Do you agree from the left and the right, those y values look like they're going to 2 when my x's are going to 0? Cool, cool, cool. Final answer?
0.
Boom. Okay, this next one says, hey, this is very AP-ish. For each of the following values, A is 1, 2, 4, and 6. Find the limit as x approaches A. Notice this A is reflecting right there all those A's. So we're going to have to do 4 different limits. Or explain why that limit doesn't exist. Use correct limit notation. So this is when we hate writing that limit thing, but Biscuit, this is when you got to do it. Sound good, buddy?
Got it.
So again, this A is 1. Let's go plug that right there and let's write the first one. So we're going to say, all right, the limit as x approaches 1 is the first one of my function. So we should also put that there because again, I'm just getting that notation from right there. Which should I look at, the table or the graph?
Graph.
Yeah, because they said F. So let's go to the graph. As x approaches 1, people, what would you say that limit is? Right. How would we do that with correct limit notation? We did that once yesterday. We're going to say does not exist because, anyone have any idea? The limit as x approaches A from the negative side does not equal the limit as we approach A from the positive side. So much jumble, right? This is how we're going to say it. The limit as x approaches 1 from the negative side of my function, because we got to make sure that we're saying of the function, as he said, does not equal the limit as x approaches 1 from the positive side of that same function. That's how we would note that. So now I'm going to do same notation. Again, Biscuit's like, so much notation. Biscuit, I know you're not really complaining. I just like to put words in your mouth. Limit as x approaches 2. Limit, not f of 2. What's the limit as x approaches 2? Would you guys agree? I can't. Okay, you guys get it. Now, we have to show no reasoning for that. If we've got that limit, boom, it's right there. What's our next one? As x approaches 4, limit as x approaches 4 of my function is, Marmar, what do you think, buddy? You got it, dude. Limit as x approaches 4, my fingers come together at -1. If you can just say that limit is -1. And finally, my last one is as x approaches 6. And I'm going to do that. I need to really get some better colors going on here. Here we go. The limit as x approaches 6 of my function
Does not exist.
does not exist. Why is that?
Because x approaching 6 equals infinity.
Yeah, we're going to say the limit as x approaches 6 from the negative side of my function is infinity. And the limit as x approaches 6 from the positive side of my function is infinity. So we're going to put both those. Sound good, Koopy?
Yeah.
Okay, 2 more. It says, hey, I don't think we're ready for this one. We're not ready for continuous yet. You can cross out C. Write a difference quotient. Does anyone remember what difference means? Add, subtract, multiply, or divide. Yeah.
Subtract.
If we can't see the top.
So it says find the difference quotient, something that uses subtracting to approximate instantaneous rate of change. And we really haven't used that term much. That's just a really fancy term to say slope. Guys, what's the equation for slope? That slope-intercept form. Appreciate you, Harville. Slope is just
Y's change. Y.
Change y over
changing y over changing x. Y minus y over x minus x, right? So they want a y minus y over x minus x to help us approximate that slope at 0.
You do the h thing, you like add h to the first.
Oh yeah, we could be excessive. And this one I'm really not that worried about. And oh, the slope of g at 0. I was like, the slope, okay. The slope of g at 0. Think about this. The slope of g at 0. Do you agree g at 0? 0 is going to be about right there. How could I find the slope pretty close to that? Change a y over change an x.
You just take the y from, you can do, yeah, you can do 1.99.
Yes. He's saying, oh, use these 2 points. This is an x, that's a y. This is an x, that's a y. So I could do change in y over change in x. Do you think he's more accurate doing this green pair? Or what if Henry was like, I'd rather use this point and this point? Which point pair is going to be more accurate? Because which pair is going to be more accurate to estimate my slope at 0?
It's not required.
The green or the red?
The green.
Green, because it's going to be closer. Henry, I didn't mean to throw you under the bus. I just used your name. Okay, so just like you said, we're going to do change in y over change in x. All I would do is I do 2.001 minus 1.999, or you could do it flipped, Ritzy. It doesn't matter, right? Over 0.001 minus negative 0.001.